we are going to start with the next topic, that is the pH scale. pH scale, my dear, it's a scale that is going to start from 0. It goes up till 14, and its center point, that is the 7, which is called as the neutral point. It's a neutral point. Okay. So from 0 till 7, okay, and then 7 till 14. 7, that is the neutral point. This is the pH scale. So what is meant by the term neutral point? What is the thing neutral? So last time I have told you, my dear, that any substance that produces H positive ions in its aqueous solution, that is called as the acid. Okay. And the second thing, keep remember, anything that produces the OH minus, so that is called as the base. Okay. So in the neutral solution, what would happen? You people have got the H positive and OH negative. So the concentration of H positive and OH negative, they are exactly same. They are equal to each other. Okay. If you move down the pH 7, okay, so it would start becoming acidic. Why it will start becoming acidic? Because the concentration of H positive ion is now greater than the OH negative ion. So now keep remember, my dear students, that most of the students, they get confused with the term acid. Acid दुनिया की हर वो चीज होती है, I have told you, which produces H positive ions. Okay, so acid do contain OH negative ions inside it, but the concentration of H positive ions, that is greater than the OH negative ions. Okay. So if the concentration of H positive would become greater than OH negative, so the solution becomes acidic. If the H positive and OH negative concentration amount, that is same, so that thing is neutral. Okay. So if you move above 7 pH, so the thing that would become basic. Okay. So in bases, what would happen? The concentration of OH minus, that is greater than the H positive ions. So my dear, keep remember, if it is the acid or if it is the base, okay, so both of the things, they contain H positive and OH minus ions. In case of acid, the amount of H positive ion, that is greater, the amount of OH negative ion, that is less. Let's suppose in the acid, the amount of H positive ion, that is 5,000. The OH negative ions, they are 1,000 only. Okay. If you move towards the base, so the OH negative ion amount, that is, let's suppose 4,000. The amount of H positive, that is less. This is 500, let's suppose. But if it is a neutral solution, the amount of H positive and OH negative, my dear, they are exactly same. You got it? You got it, guys? I'm getting
yes, sir.
better. At least yes or no. Okay. So now keep remember, any solution having the pH between 0 and 7 or less than 7, so that solution would be the acidic solution. Keep remember, from 0 to 2.4 pH, that is the strong acid. That is the pH of strong acid. Okay. And from 2.5 to 6.9, that is weak acid. Okay. If the pH will start moving towards 7, the acid would become weaker. Keep remember that. Okay. And just like that, if the pH, that is 7.1 to 12.5, so this one is weak base. Okay. And the pH 12.6 to 14, that one would be a strong base. You got it, beta? So till now we have discussed the two things: pH scale. In pH scale, I have told you it is going to range from 0 to 14, and pH I have told you yesterday how could you calculate it. It is the concentration of hydrogen ions. So hydrogen ions, they are present in the acid and in the base as well. If you see, the bases do contain H positive ion, but the H positive ion amount that is less as compared to OH negative in case of bases. But in acid, the H positive amount that is greater than OH minus. So here, the amount that is greater, I have told you pH could be calculated by taking the negative log of a value. So if the bigger value negative log is taken, the value would become smaller. And if the smaller value negative log is taken, the pH, the answer would become bigger. So that is why I have told you yesterday. You got it? Beta, this is your first day?
Second day.
So you have taken the class yesterday?
Yes.
That's fine then. Okay, beta, anybody got the problem up till here? You can ask me.
No, sir.
Okay. Now we are going to start with the next thing, that is the measurement of pH. So how could you measure the pH? Okay. So there are the two methods. The first method, that is the pH meter. This is the first method. Okay. So this is a beaker. It is having a solution inside it. If I'm going to ask you that what is the pH of that solution, what should you do? You should take a pH meter. It is going to show you the reading up here. It has got a wire. Dip the wire in the solution, and the pH meter, it will show you the reading that what is the pH of that solution. Okay. So dip the wire of pH meter in the solution. The pH of solution will be displayed on pH meter. Okay, the pH meter, it will show you the reading. Let's suppose it's 2.4. So it will show the reading 2.4 like that. So it means the pH that is 2.4. Okay. Okay, my dear. So the second method by which you can measure the pH, that is the universal indicator paper. So universal indicator paper, it's a paper which is actually yellow in color. If you see this thing, whatever this thing, okay, so this is yellow in color. So keep remember the universal indicator paper, that is also this yellow, same yellow. Okay. So what should you do if you want to find out the pH of any solution? Okay. So take that solution. Okay. So this is actually a paper. So dip the paper in that solution. Okay. So this paper would become colored. Okay. Now you have got a range of coloring chart up here. Let's suppose 1 pH, there should be some color, 2 pH some color, 3 pH color, different color. Now compare the color of this universal indicator paper with this coloring chart. This is the coloring chart. Okay. So where the color that is going to resemble, that would be the pH of that particular solution. Okay. So it's very simple, my dear. Universal indicator paper is actually a paper. You just take that paper. It's a strip, just like yellow strip. I told you like this yellow. Okay, this is the yellow color. So it's a yellow strip. You just dip it in the solution. it would become colored. So you have got a coloring chart, okay? So compare the color with that coloring chart, where it is going to resemble, that would be the pH that would be written on it, okay? So this is the second method by which you can find out the pH, okay? So dip, the universal indicator paper in a solution and compare the color of paper with a coloring chart. Okay, so these are the two methods, my dear students, by which you can find out the pH. So till now we have discussed the two things. The first thing is pH scale. It's going to range from 0 to 14. 7 is the neutral point. At 7, H positive and OH negative both ions are present and they are equal in amount. As the pH decreases from 7, the solution would become acidic, and in acidic solution, the amount of H positive that is greater and the amount of OH negative that is less. So it's this thing is greater. So it's a crocodile mouth that always opens towards a bigger thing. Okay, so this thing is bigger, this one is smaller. Just like that, if the pH would becoming more than 7, so that thing start becoming basic. And in basis, the OH minus ions, they are greater in amount than H positive ions. Okay. So I have told you the strong acid and weak bases and strong bases. Then measurement of pH, it could be measured by means of the two methods, pH meter and the second one, that is the universal indicator paper. Okay. Okay, beta, the next part of the acid and bases, that is the indicators. What are the indicators? Indicators are actually the solutions, okay, which changes their color when you are going to put them in acid and base. Okay, let's suppose you have got an indicator. Okay, so this indicator is colorless. If you are going to put it in the acid, it would become red in color. If you are going to put it in the base, it would become blue in color. So the same indicator, it will give different color in the acid and different color in the base. The same indicator. Okay. So indicators are actually the solutions which changes their color when they are added in some acid or base. Okay. So just note it down. Indicators are the solutions which changes their color when added in acids or bases. Okay, you got it, guys?
Yes,
Yes,
sir.
sir.
Okay, so the three indicators colors you should know. Okay, the first indicator that we are going to use, my dear, that is phenolphthalein. Phenolphthalein is an indicator. In acid, it is colorless, and in base or alkali, that is pink in color. Okay, the second one, that is methyl orange. Methyl orange in acid, that is red. In base, It is yellow in color. Okay. And just like that, my dear, the last one, that is universal indicator solution. So you have got the universal indicator paper and you have got the universal indicator solution as well. Okay, so solution and paper, these two are the different things. Okay, so this is the solution. So universal indicator solution in acid, that is red, whereas in base it is blue in color. So these three indicators, they are present in your syllabus. You should learn these only. If in the question he is going to provide you some other indicator, he is going to mention their color change. Don't you worry about it. Only these three, they are the basics. So you have to learn the colors of these three indicators only. You got it, beta?
Yes, sir.
Yes, sir.
Okay, guys. Can I rub this one?
सर एक सेकंड जरा रुकिएगा.
ओके सर क्लियर बेस सेम होती है. नहीं करते हैं भैया, अभी वो शुरू करने लगे. एल्कली एंड बेस, एल्कली बेस तो होती है, ठीक है, लेकिन हर बेस एल्कली नहीं होती. इट इज वन ऑफ द टाइप ऑफ द बेस. ये भी बेस बताता हूँ, आपको क्लियर नहीं होगा, कंफ्यूज हो जाओगे. The very important thing, that is the base, basis. Okay. Before starting the base, let me draw a table up here. Okay, my dear students, everybody now focus, stop writing, everybody. Have a look, my dear students, this whole thing that is called as the periodic table. Okay, so periodic table is a table which consists of at least 220 different elements. So these numbers, they are actually elements. Okay, so now what should you do? I've just written some of the elements up here. Why? I'm going to tell you about it. First of all, this is vertical columns. These are called as the groups. This is group 1, this is 2, this is 3, this is 4, this is 5, 6, 7, 8. These things are called as the transition elements. And these are also the transition elements. Okay. Now what should you do? You just put a line at the base of one element of group 3. Okay. You should put a line under 2 elements of group 4. You should put a line under 3 elements of group 5. You should put a line under 4 elements of group 6 and join all of these lines like that. Join it. So my dear students, you are going to get a staircase. So this is a staircase like that. Okay. So all the elements which are present under the staircase all these elements, they are called as the metals. Whereas the elements which are present above the staircase, all these elements, they are called as the non-metals. You got it? So this is the periodic table here. In the periodic table, you should put a line under one element of the group 3, then group 4, 2 elements, then 3 elements, then 4 elements, and join all of these lines. So you will get a staircase. Okay, so all the elements which are present under the staircase, they are called as the metals, whereas all the elements present above the staircase, they are called as the non-metals. Okay, so why I have told you this thing, I'm going to tell you right now. Okay, so let's start with the basis. Okay, so this is a common mistake most of the students they do. Okay, base, if somebody asks you that what are bases, okay, so keep remember, my dear students, if with the metal an element oxygen is attached, okay, or with the metal the hydroxide that is being attached. Hydroxide is OH actually. Okay, so all these things, have a look up here, all these things, they are metals. Okay, so if you take any element from here and join oxygen with it, or any element join OH with it, so that thing would become the base. So that is called as the base. You got it? So if you people want to define the base, okay, so bases are actually metal oxides and metal hydroxide, and what the things are metal, in papers periodic table is provided to you. Okay, so what should you do? You just draw a staircase on it. Okay, so all the elements present under the staircase, they are metals. Take any of the element. Let's suppose here one element is present, calcium. If I'm going to join calcium with oxygen, or I'm going to join calcium with OH, so both of these things, they are bases. You got it? You can take anything from here. Let's suppose iron is present up here, so you can join FeO or FeOH twice. So both of these things, they are bases. So any metal oxide or metal hydroxide, so that thing is called as the base. Is it clear, my dear? So this is the common definition of the bases. So this is bases are metallic oxides and hydroxides. Is it clear, my dear?
Yes, sir.
Okay. Now we are going to move towards the next thing. Bases, my dear, they are of two types of bases. Okay, so bases, they are of two types. Okay, the first type of base, that is called as the soluble base, and the second one, that is called as the insoluble base. So the soluble bases, they are also called as the alkali. Okay, so only those bases which dissolves in water, okay, they are alkali, whereas the bases which are insoluble in water, they are insoluble bases. Now we have to learn that which bases are soluble in water, okay, and which are insoluble in water. So this is very simple. Okay, so keep remember, only group 1 and group 2. So this group, group 1 and group 2 metals, oxide and metal hydroxides, they are only soluble in water. Okay, whereas all these metals, if the oxygen is attached with them or hydroxide is attached with them, all these, their oxides and hydroxides, they are insoluble. And if something is insoluble, it will form the precipitate. Okay, let's suppose this is the bottle. Okay, if I'm going to put my finger up here, you can see my finger from here. But if this one contain, let's suppose the milkshake, and I'm going to put my finger up here, you people are unable to see it. Why? Because this milkshake contains the precipitate solid particles inside it. Okay, so if you put these metal oxides and hydroxide in the water, they are insoluble. They form the precipitate. If you put these metals oxides and hydroxide in water, they are soluble in water. And one more thing, my dear, group 1, 2 metal oxides and hydroxides, they are only soluble in water. And one more thing, there is a gas which is called as the ammonia gas. So this one also dissolves in water, and when it dissolves in water, it produces the OH minus ions. So that is also the soluble one. Okay. So keep remember, if you want to define the soluble base, so any base that dissolves in water and produces OH minus ions is called alkali or soluble base. So keep remember, my dear students, I'm going to tell you one line that all alkalis are bases, but all bases are not alkalis. You got it? All alkalis are bases, because alkali is one of the type of base. It's a soluble base. And if somebody asks you that which one is the soluble base, so the answer is very simple. You can take any element from group 1 or group 2, just join oxygen or OH with it, and you say this oxide and hydroxide is only soluble. Whereas all these metals, their oxides and hydroxides, they are insoluble in water. Okay, so they are the insoluble bases. You got it, guys?
Yes, sir.
Ammonia is a gas. It dissolves in water and produces OH minus ions as well. So that is why it is also alkaline. Okay, so I have given you the definition. Anything that dissolves in water and produces OH minus ion, because water is a neutral solution. It contains H positive and OH negative same. If you put anything, that will increase the OH minus ion concentration. So OH minus thing I have told you, that would become basic or alkaline. Okay, so you can keep remember, my dear students, you can only measure the pH of alkalis. You can't measure the pH of bases, insoluble bases. Because insoluble bases, they can't dissolve in water. So you people are unable to measure its pH. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Write this thing up here as well. We can measure the pH of soluble bases, alkali. We cannot measure the pH of insoluble bases. Okay, my dear students, I'm going to repeat this whole stuff for you so that you can understand it fully. First of all, we have started with the basis. I have told you this is the periodic table. You can draw a staircase up here, and the elements present, all these under the staircase, all these elements, they are metals. The elements present above the staircase, they are non-metals. If you take any of the metal from here, join oxygen or OH with it. So that thing would become base, and bases are of two types, soluble and insoluble base. Soluble bases are alkali. Okay, so those bases which dissolves in water and produces OH minus ions, they are called as the soluble bases or alkalis. Okay, and I told you only group 1 and group 2 metals, oxides and hydroxides, they are only soluble in water. Whereas ammonia is a gas that is also soluble in water and produces OH minus ion. So that is also basic. Okay, so that is also alkaline. Okay, so I have told you another thing, all alkalis are bases, but all bases are not alkalis, and we can only measure the pH of those bases which are soluble in water. The base which is insoluble in water, let's suppose if somebody asks you what is the pH of iron oxide, iron is present up here. So your answer should be, we can't find out its pH. Why? Because it is insoluble in water. You got it? So keep remember this stuff, because most of the students, they get confused with it. They just listen the name of the base and they say, oh, base, it is having the pH above 7. But keep remember, all bases are not having the pH. Only those bases which dissolves in water, okay, they are having the pH only.